So I can bring back a jit.gen, and we can look at some of the other ways in which we can manipulate the random values coming out of the jit.noise. So we'll dive into our jit.gen here, and in this case we're going to bias at the end. First we're going to multiply. I'm going to delete my inlet 2 because we don't need it. Go up to Monaco 14 point and move things a little closer together. So here we're going to multiply, but we're going to multiply proportionally. We're going to multiply the x, y, and z values differently. And to do that, I introduce a new object, which is the vec object, or vector, which allows us to set a multiplication factor for the x, the y, and the z separately. So for instance, I can multiply my x by 2 while multiplying my y and my z each by 0.1. And this is going to create long rectangles. They're all going to be of random length, but they're all going to be proportionally multiplied by 2 on the x-axis, but only by 0.1 on the y and the z-axis. So let's take a look at that. Right, so now I get a bunch of sticks, basically. And those sticks are spread out over the 10 meters that I've specified here. So this is, again, the idea of scaling. I'm taking the random values between 0 and 1. I'm multiplying all the x values by 2, multiplying the y values by 0.1, the z values by 0.1. And I can change this to taste. So I could do multiply x by 3, y and z by 0.3, and I'm going to get thicker blocks. Of course, if I don't want them as spread out as far, I can go back into my position and lower the scaling of my position so they're spread out over 5 meters. And now there's a few collisions in there, but not as bad as when they were all being created in the same place. There's going to be a few collisions because these are large physical objects being created at random locations. So here I've scaled first, and one possibility that exists here is I can have a dimension of 0. For instance, if my x is 0 coming in, which is one of the possibilities of the random number generator, 0 times 3 is still 0. So I can have an object with no width along the x dimension. And that's true of any of these. Also, I can have extremely, extremely thin values. So for instance, if I have a value of 0.1 coming in on the y, 0.1 times 0.3 is going to be 0.033, which is, again, a very, very thin object. So here I can scale and then bias, and that creates minimum scale amounts. So I can just say I want to add 0.1 to everything. So after the multiplication is done, scale everything up by 1/10 of a meter. So scale and then post-scale biasing. And that's just going to mean the thinnest dimension I can have is going to be 1/10 of a meter. And here we can see what effect that has. There's a minimum thickness set. So you're going to, and I'm going to want you to work with this in the homework, the difference between biasing and then scaling as opposed to scaling and then biasing. And also I'm just going to mark, I mean, these are really all new objects. So I'm going to mark these all in green so you can see that these are new objects that we're working with here. So we have a color randomizer, which doesn't affect scale or position. We have a position randomizer that puts each object in a new position, and we have a scale randomizer that randomizes the scale. And of course, we can take one button, connect it to all 3 of these buttons, holding down Shift key to make it quick, and it'll randomize all 3 at the same time. So you can randomize isolated things, or you can randomize all things. Now, of course, we're going to go past randomization. One of the problems with randomization, even though it can create some interesting structures, is it also introduces a certain lack of control, and we're going to want to get some of that control back at a later point. The last thing I want to introduce with regard to this is, you've probably realized that this jit.noise is creating an image, even though we're using that image to color the blocks differently, position the blocks differently, scale the blocks differently. Also, jit.noise 3 float 32 and some value creates an image. And we saw that in the jit.p window. So maybe some of you have already got to, could I use that image as a texture to texture my objects? And the answer is yes, but an image can't be one-dimensional. It can't be 20 pixels wide. It has to be 20 by something. Even if it's 20 by 1, that's a valid image. So I'll create a very simple image here, a 2 pixel by 2 pixel random image, which is going to give me 4 squares of random color. A 10 by 10 is going to give me 100 squares of random color. And this is an image that I can apply to the material on any object. So let's just create a whole new jit.gl.grid_shape at shape cube. There it is in the middle. And we created this route enable here so that we can disable our multiple if we want. I can say enable $1, attach a toggle here, target 0, enable $1, disable all of those objects. And here's my grid shape. I'll make it scale 2. I'm going to connect a jit.gl.material to it. And I'll take this random image that I've just created and send it into the jit.gl.material as we did with textures previously, and it colors the object. Now what it does is it takes this low resolution image and stretches it so you can see that image gets blurred. You can use this to nice effect. For instance, let's go back to that simple 2 by 2 image, which creates 4 squares of color. It's going to stretch those 4 squares into a gradient, a 4-color gradient. Take this and encapsulate it to make a little bit of space. Call it whatever I want. I'll call it iter. So here I've got my jit.noise becoming the texture on this object. Now, if you don't want this blurring, you need to increase the resolution. But as we increase the resolution, we get more squares. So I can do 100 by 100, which is going to give me a crisper image, but so many colors. And if I want a really crisp image, I have to go up to 1,000 by 1,000 pixels. And you know this from digital cameras and from smartphones. The higher the resolution of an image, the crisper it is. The problem is the noise is getting finer as the resolution goes up. So here's our first actual use of the jit.matrix object. I'm going to make a very simple 3 by 3 grid of noise, which the jit.gl.material is treating as a 3 pixel by 3 pixel image, and then taking it and stretching it out. But we can take the jit.matrix, insert it here, and we can say jit.matrix 3 float 32 1000 by 1000. In other words, take this image and scale it up to a very high resolution image. And then we need to add at adapt 0, meaning a matrix will typically rescale itself to the size of the incoming matrix, which in this case is 3 by 3. We want it to keep its resolution of 1000 by 1000 so that we get crisp edges on the image. And that's it for this tutorial, and there'll be a homework assignment corresponding with this as well.